Welcome to the second in our Masters of Reliability webinar series. Today's topic is St. Charles Proactive URD Asset Management Approach. My name is Chrissy, and I'll be your moderator for today's session. Please submit your questions into the chat feature, and we will address them after the presentation. I will now hand it over to Rich Brinton, Vice President of Market Development at Novinium, to introduce our guest speaker.
Thank you, Chrissy. Joining us today is our guest speaker, Tom Bruhl, Electrical Services Manager at St. Charles Municipal Electric Utility in Illinois. Tom Bruhl is a professional engineer and was graduated from Purdue University with a degree in mechanical engineering. He started his career working at ComEd. He now manages the planning and maintenance activities for the transmission, substations, and distribution for the City of St. Charles. Tom, welcome. I will now turn the presentation over to you.
Thanks, Rich. I appreciate Novinium giving us an opportunity to share what St. Charles has developed in this arena. And with that, I'll go through the agenda for today. I'll start with the problem that St. Charles experienced in the mid-2000s, specifically related to residential single-phase underground cable failures. How we planned or came up with a plan to address those that then developed into a project that we had to present to City Council to actually get funding and proceed. What the results we had through our project, which is now about 5.5 years old, because we're only partially through the whole project, I'll talk a little bit about what we're doing or where we're headed next, and then I'll summarize, and then we'll have some time for questions. So just a little bit of background on St. Charles. We are in northern Illinois. We are about 40 miles directly west of downtown Chicago. We have a long history of being a municipal electric utility that dates back to 1892, so that predates Sam Insel building electric lines out of Chicago that became ComEd. So we are part of a number of towns along the Fox River that are municipal owned and surrounded by Commonwealth Edison. We have approximately 15,500 total customers, of which 13,000 are residential. Our population by the last census was about 32,000, so that ends up being about 13,000 residential meters. Our demographics were probably a little bit higher than average in terms of median income in St. Charles. We have some million-dollar homes with movie stars living in them. But we also have a number of working class neighborhoods. So I would say on average we're a very typical suburb of Chicago, west suburb. Our system is approximately 80% underground at this point, so we've done a lot of active overhead underground, and there are some new sections of town that there isn't a pole anywhere in the whole quadrant of the city. But even with that, that comes with about 600,000 feet of single-phase cable that was put in all of these subdivisions that were developed in the 60s, 70s, and 80s during the boom for St. Charles population. So we have a lot of older or aging residential cable in people's backyards. So here's the problem. For everybody here, hopefully is familiar with SAIDI, which is the System Average Interruption Duration Index. This is how many minutes per year the average customer in your city is without power during the year. And we had been clipping along in the 30 minutes type area. And then through the mid-2000s, we got into the 100 minutes. So that's, a 100% plus increase in the number of customer outage minutes. And that was definitely something that our city council and elected officials and our population identified as a concern. And at that point, the electric utility was told to come up with something and fix it. So the reason for the bubble here that we see in the mid-2000s was a majority caused by some pretty major single-phase cable faults in people's backyards that led to long-duration sustained outages. So our cable faults actually got worse in the 2010-11 as we were just getting into the program, but we did have a sharp spike in these cable faults through the mid-2000s. So we would go from 5 or 2, which was pretty manageable and not very impactful to your SAIDI number, to 2 years in a row at 10. And when you're averaging 1 a month, sustained outage in a residential area, that obviously is going to draw some attention from your customers. So the work I'm talking about here today is our senior distribution engineer. His name is Steve Schreiber. He has a long tenure with Commonwealth Edison and then with the city of Naperville in Illinois prior to coming to St. Charles. He's a very modest man. So I am here on his behalf sharing some of the brilliance that he's put into our complete plan to address our URD cable. So his program that he laid out, first we identified all of the cable that we had in the ground. We had to prioritize which subdivisions and where we were going to go first. And then obviously he started with addressing some of the areas where we've already had cable faults, in some cases, a number of cable faults. So what the plan looks like is a pretty interestingly colored spreadsheet in Excel. It's nothing fancy, but I'm going to go through the different elements of how we prioritize based on a multifaceted. It's not just age, it's not just previous problems. There's a number of things that Steve boils into why a certain subdivision is the next one to get reinforced. So we start with subdivision and subdivision age. That can be very difficult. I understand that, to try and figure out where all the subdivisions are. We use the GIS mapping-based system to try and pull the pieces of the city apart in chunks using subdivisions. And in terms of age, we would go to the plat of survey or plat of subdivision from when the plat was recorded to get an age. Another trick we used was transformers many times will either their serial number or some of them actually have a year or a date of manufacture, month, year of manufacture, to try and at least get a feel for what span of years that subdivision was built in. Okay, so here it is a little closer. The next thing we did is we looked at how many faults has the subdivision had. Obviously, if it's already had 1 or 2 faults, we got to, that's going to take a higher priority to something that hasn't had a problem yet. Traditionally, we would wait till a subdivision picked up its second fault, and then we would send the directional boring crew in and replace every cable in the subdivision after a second fault. But due to the timing on that, with how our budgeting works, so a subdivision would have its second fault, then we'd have to figure out how much it's going to cost in terms of an estimate to replace that. Then we'd have to put that in the budget process, which is an annual process, and if you just missed it, then it could be a whole other year till that comes around. So in some cases, it could be 18 months or 2 years before the boring crew got into some place that just had its second fault. And in some cases, we ended up picking up a third fault, and that obviously drew a lot of ire. The other thing in terms of fault rates, and when we talk about customer impacts, is we are a fuse saving recloser strategy company. So we will take a momentary on a cable fault to see if it was a tree branch or something or a animal contact that's going to clear. So not only did all of these subdivisions that have faults have the sustain for the people unlucky enough to be past the fault or past the fuse, but then that whole circuit experienced the momentary. So not only when you're having 10 faults, there are 10 neighborhoods that have some sustained outage, but there's also, in some cases, hundreds, if not many hundreds of customers who you get the calls that they have to reset their clock because they had the momentary on the recloser. So the next thing, which I think is very special with what Steve has embraced and has put together here, is to determine the insulation quality of these old cables by using VLF tan delta. And for the folks who might not be familiar with it, it's very low frequency. It's 0.1 hertz testing. And then the tan delta element basically is a power factor test for the cable insulation value. And there are IEEE standards for new cables, and that's what we reference when we test before and after. So what's one of the clever things that people pick up on when they see Steve's spreadsheet here is his skull and crossbones. Everybody loves that. Those indicate places where Steve had the test rig, and before we got to the rated voltage of the cable, the sine wave at the top of the amplitude in terms of voltage starts to collapse. And that's indication that the cable is on its way to failure. And at that point, anytime we see that, we immediately shut down the machine. I'll note that those spans that did fail VLF, meaning that they're a ticking time bomb and they're an imminent failure, we didn't change any of our plan with that in terms of our injection, and all those spans ended up being injected and went on their merry way. So, all right. The next thing is age. It's obviously an element. We find it not to be a primary element. We put it in there. If all things are equal, then we're going to do things by age, but it's not a very highly weighted piece of our puzzle here. But what is a heavy piece is what would be the fault's impact on customers. Is it a radial location that's going to be a long sustained outage and we're going to have to dig up and splice? Or are we talking about a loop that we've got some monster loops with 20 single-phase transformers on it? That's obviously going to be much more impactful in terms of customers and your SAIDI compared to something that's a 3-transformer loop. So Steve goes through and identifies within the subdivision whether it's going to be something more impactful if we did have a failure. Okay. So at that point, we thought we had a pretty good plan where we had figured out what subdivisions we had, what the population of cable was, and what the priority was. And what we did is we had to get budget for this, and we recommended a hybrid cable replacement, cable injection. So it's the first time that we were injecting cable. This was like in 2009 we started injecting cable. It was a new concept to us, and we went to City Council, explained how we're going to prioritize the subdivisions, and that to maximize our available budget, should they approve the project, we would be prioritizing on cable injection, which at the time we felt was about 50% of the cost of traditional replacement. It turned out to be closer to a third, only a third of the cost. But at the time, we sold it as the more we can inject, if we could inject everything, we could do double the cable for the same budget money. So through that, we could maximize how much of the cable assets we were going to get through in a given year, and it was obvious it was going to be a multi-year project. Even if we were given unlimited funds, there isn't enough manpower to replace all of the cable in the city of St. Charles that quickly. And obviously, we felt that was the most cost-efficient way to improve reliability if we could embrace cable injection and rejuvenate as much cable as possible in a short period of time with the limited funds. That would be the best way to turn our reliability problems around. So in 2009, we started injecting our first cables. The process starts with Novinium assessing each cable within the prioritized subdivisions. So we started at number 1, and Novinium and the city crew went in and started looking at the different cable spans. I wanted to talk a little bit about the injection process. Novinium offers 2 different processes. One is called sustained, and in a sustained process, which we prefer and we prioritize, you inject the fluid under a higher pressure, and in general, most times for our span lengths, it's an hour, hour and a half, 2 hours. The cable or the fluid is from one end of the cable to the other end of the cable. You seal the ports, put the elbows back on, put the put the cable back in service, and go to the next one. So sometimes we're getting 3 and 4 spans per day done using the sustained method. If there are accessible splices that would otherwise have not allowed the flow of the fluid, we do dig those splices up and inject using a special splice that lets you inject from the splice back to the termination point, whether it's on a pole or in a transformer. So we will, if there's a splice, sometimes we'll skip it if we didn't know it was there. Other times we'll dig it ahead of time and just go right to there and inject both ways. For inaccessible splices that will flow, so you can imagine in 30, 40-year-old neighborhoods, you name it, we've had it in the backyard. People there's a shed, there's a patio, there's a pond, there's a pool. There's a number of different things that are in conflict with being able to dig up and fix that splice. If that splice will flow air, which is one of the tests Novinium does to make sure that the fluid will flow down the cable, we will go to what's called unsustained. And the only downside we see with the unsustained is that it does require a second trip. So you have a bottle reservoir under pressure at one end, and then you have a receiving bottle at the other end, but that is not a one-day process, so it ends up being a second trip, a second interruption into these people's backyards, and obviously the labor to make that second trip. It goes without saying, if you can't get at the splices or you can't flow the fluid, then you end up just having to send in the directional boring crews. One of the things that a lot of people don't take into account, but we have, is that as part of the Novinium testing on each cable before we inject it, if the neutral is more than 50% corroded, we have determined that we do not want to save that cable. We're going to go ahead and replace it, put new jacketed cable and pipe, and not inject a cable where the concentric neutral is more than 50% degraded. Through that, the little circle here, depending on subdivision, most of the spans were able to rejuvenate using the sustained process. Based on how people installed cable in the 60s and 70s, where they would put a trencher in the ground and they'd run the cable in the trench, and then at the end of the cable they'd direct bury a splice and just keep going. We had ended up with a lot of splices, and with a lot of the neighborhoods, they were very difficult to dig up. So we did end up with a significant number of unsustained injection spans. And then there's about 10% of the spans that you end up just not being able to inject due to either inaccessible splices that don't flow or corroded neutral. Okay. Steve and I have been pretty open about the fact that the effort is to get as many feet and spans of cable rejuvenated and reinforced as fast as possible. And even though we prefer sustained or we prefer injection, we're going to do whatever we got to do in that subdivision. So if we can't get sustained on that span, we'll do unsustained. If we can't get unsustained, then within 30 days, we're out there replacing the cable with traditional means. In the event that you have a difficult to access splice, but it will flow fluid, by being flexible and accepting the unsustained process, which again takes that second trip, you get the cable rejuvenated at a lesser cost than traditional directional boring, and you don't have to dig that splice. I can't overstate enough how the customer experience from cable injection is different from traditional directional boring. As I talked about all the problems in people's backyards, that amplifies when you actually have to send a mini backhoe in there and dig a hole in front of their transformer, then get a directional boring rig into somebody's backyard. You have to dig all kinds of potholes wherever you're crossing some other utility, so there's it's not just a hole on each end. There's a number of holes in between the two ends of the directional boring span. And then after the directional boring is done and you've disrupted the yard, even after you've backfilled, then the city crew is coming in to replace the cable, and that's another day or two that their backyard is disrupted. Many of these people have fences, and they have to keep their dogs in, and people don't want their kids out while there's construction going in their backyard. So it is really impactful to these residents when you have to do traditional replacement. And we got all kinds of complaints about that, but the most significant complaint we would always get is, and we still get for the places where we have to traditional replace, is the landscape restoration. It is oftentimes not to the people's satisfaction, and those people are going to voice their complaints, and they had some special hosta that you can't replace, or you disrupted some mulch bed that now has a lot of weeds. And no matter what it is, we end up dealing with a lot of administrative time with the quality of the landscape restoration. And that is a detractor from our overall image, as those people then, when they're not satisfied with how the seed came in, that they're calling their alderman, and then we end up engaged in conversations that we'd rather not be engaged in. So with the injection process, we notify people that we're going to be in the area. We're not digging any holes in their backyard. People are there for about 2-3 hours, 4 at the most. We close everything, lock it up, and we're gone, and we're never back. So in a perfect sustained process, we're interrupting these people's lives for maybe half a day at most. And then I will highlight that all of it's for naught if you end up with a cable fault on something that you had to bypass because you couldn't inject it. So we do prioritize that in the 10% cases where we do have to actually come in with a directional boring rig, we try and get that done within 30 days so that we don't pick up a fault in a subdivision that we're trying to reinforce. So how that works in terms of footage is, in our 5 years, we've done about 235,000 roughly feet of subdivision cable. So we're getting near the halfway point. About 52,000 feet have had to be replaced via traditional means. And then here's how the other almost 200,000 works out in terms of sustained versus unsustained. And again, maybe our installation methods are different than others, but we have had a lot of splices in this cable from the 60s and 70s. One of Steve's strengths in terms of diagnostics and selling this to both me and to the City Council is the use of tan delta and power factor testing this cable before, and then we made him go back afterwards. So Steve went back at 6-month intervals after injection of the spans that were originally targeted as test spans, and he VLF tan delta'd them for 15 minutes after 6 months, 12 months, and 18 months. What was surprising to us, but not surprising to Novinium, was that at 6 months, actually the tan delta results got a little bit worse. So the cable was appearing to continue to degrade with respect to insulation value. At 12 months, it was back to where it was before injection or a little better, and by 18 months, it was testing like IEEE brand new cable that you'd put in the ground and buy today. What we had to understand is that it's not a miracle fluid. It is injected down the strands, down the center of the cable, and it's going to permeate through the insulation and fill the trees and voids, but it doesn't happen immediately. It takes some time for that fluid to permeate through the insulation. So that's why after 6 months, on some spans, it just hasn't gotten to fill all the trees that it needs to fill to restore the insulation. So now I've got a pretty good history of 8 years before we started cable injection, and then 5 years after we started, or after we embarked on this really aggressive cable replacement plan. So that population of failures is 66 at this point. Again, the majority of those before we started injecting or in the early stages, but we've had only 3 since we started doing the cable injection and the aggressive replacement. In the 3 that have failed, they were all very early after cable injection. I think one within a week and the others certainly within 3 to 6 months. And those are indicators for us that we are exactly where we need to be. We injected it. We were maybe 3 or 6 months late. Had we been just 3 or 6 months earlier, we would have probably avoided that fault. But it gives us the confidence to know that we are not injecting subdivisions well before they need to be injected. At this point, we feel we're right at the cusp where we are injecting cables that are going to fail within the next year. And that's, I think, the sweet spot that we're really, really happy with where we're at. In terms of dollars, how that works out is even though only a fifth of the cable had to be replaced, you can see that 1/5 cost us double what it cost us to inject the other almost 200,000 feet. So in the event that we had not selected a hybrid approach with prioritizing on injection first, that would have been well over $6 million. But I'll tell you, we would have never spent $6 million because we would have never gotten that budget, and we would have never had enough manpower to support doing that much cable replacement in the last 5 years. Okay, so as it was kind of obvious from the number of footage, we're still in the midst of the program. Where we feel really good about ourselves is that we are injecting subdivisions that have never had a cable fault. And if we now if we're just aggressive enough to where we're staying ahead of the faults, we'll inject it, and the fluid will have time to fill the trees before we end up having any cable faults in that subdivision. So I think that's right where we want to be. We're not in subdivisions that are still, going to have 10 years of life on that cable, and we're really prematurely replacing it. I think through unfortunately the failures we've had, we are really comfortable that we're right ahead of where the cable needs to be replaced. This has become part of our annual budget, so the alderman and the mayor and the city administrator for us are to the point where they ask each year what subdivision's next. They hear it every year. It just has become part of our routine. I've promoted the fact that we've reduced single-phase cable faults. For the 3 we've had, I've explained why those failed only 6 months or a week after we injected them, and they've accepted that. And in the same way, they've understand that we're not doing cable that still has 10 years life on it. We're right where we need to be, and hopefully we're 12 months ahead or 18 months ahead of cable faults, which means that you'll never have another cable fault in a single-phase residential environment. Okay, and it may sound interesting for some people who are still trying to figure out how to get to all the subdivisions that have fault on fault, and you're worried about being able to switch loops. We are injecting subdivisions that have never had a cable fault. So that's part of the big message, and I think that's part of what St. Charles is very proud of, and what Steve should be very proud of, is that it is possible to get ahead. So after having so many subdivisions, 20 cable faults over 2 years, to go from that and being totally reactionary to those 20 faults, and then 6 months later, we're digging all kinds of holes in people's backyards. Now we're not disrupting their backyards as much or as frequently. We're in and out, and they never had to experience the bad reliability of the cable faults. Okay, so to summarize here, one of the big things is if you can embrace testing. We are a VLF tan delta shop. Partial discharge would probably be another very reasonable testing method if you had that equipment or you were comfortable with that. But being able to assess the insulation of the cable more than just age. I think that was something that we didn't expect originally, but we bypassed some subdivisions from the late 60s in preference for subdivisions from the mid-70s. But that's what the cable testing showed us we needed to do, and we stuck with the program, and that's what we did. We have been very flexible with respect to what method we are willing to accept, so it's not sustained or nothing. If we'll prioritize, we want sustained, we want to be in and out. But if we can't get it and we can't get it to splice, then we're going to do unsustained, because that still is a tremendous benefit with respect to lower cost than the traditional replacement. Plus, even though we have to make a return trip to collect the bottles at the end, it still is not any holes or any other disruption in the resident's yard. And then we just have to remember not to forget the stuff that we have to skip because the neutral's corroded or whatever, just to avoid that PR disaster of rejuvenating 90% of the spans, but the one you skipped or missed or forgot about ends up causing a major outage. And through the VLF tan delta, we have verified that 18 months after injection, this cable is testing. On a TD, it's a 1.0. It's testing just like brand new crosslink poly cable, even though it's 1960s Essex cable. And making it a continuing program, something that becomes year over year, where you're just going to work from one subdivision to the next, that also offers us the opportunity to accelerate or slow down. So if we have a big subdivision and we want to cut it in half, and we want to do part of it this year and part of that year, when it's a continuing program, it just self-sustains and just keeps going year after year after year until we're done with all of our residential underground direct bury stuff. So I'll leave my direct contact information up here on the screen. I really love this community where we're very willing to help each other. There's no use in any of us recreating a wheel. So if there's any details that I didn't cover for you here today, you need to know more, or you need other information, just please feel free to contact me, and I'll share as much as I can with you. At this point, I'll probably turn it back over to Rich.
Thank you, Tom. We have received some questions from our audience. The first one being, why didn't you test every cable and then only replace the cables that tested bad?
Okay, the cable testing does take, you have to take all of those spans out of service. So there's some switching, there's manpower involved in having to switch spans out of service. And we do only a 15-minute, for this process, we only do a 15-minute VLF tan delta test. But we felt that by doing random spans throughout the subdivision, that would be an acceptable sample size statistically for the rest of the subdivision. So we didn't feel the need to test every single span.
Thank you. And the next question, have you had to re-inject any cable runs to extend the life cycle?
No, we have not. We're only 5 years in, so we have not been back to any subdivision that was previously injected. So no, we haven't been on the second round. But 30 or 40 years from now, I certainly expect that to be the plan to re-inject these cables. Now, I don't know if the concentric neutrals on these direct bury cables are going to unjacketed or going to be any good at that point. But there's no reason that you can't be re-injected. Okay.
Thank you. And then for the next question, you may need to ask Rich, but are there any environmental concerns with the fluid?
No, the fluid is all, it's internal to the cable, and we're not talking about tremendous volumes or quantities of the fluid. So we haven't had any of those issues. We have had a dig-in and where somebody broke the insulation and it oozes out, but we're talking less than a teaspoonful. I mean, it's not a tremendous volume of fluid that we're talking about introducing into the environment. But I'll let Rich answer if there's any more specifics about the MSDS of the fluid.
Well, the fluid is non-toxic and non-hazardous. It reacts with water, and if it happened to get in the soil, the soil microbes would actually consume it. So it is a pretty benign fluid from an environmental point of view.
And the next question, what if you could test without taking an outage?
What if we could test with PD testing? You could test without taking the cable out of service, but that we embraced the VLF tan delta in the early 2000s, and with that we need to make direct contact with the conductor. So for us, there really wasn't an option of testing without taking the cable out of service. But if that's in reference to why don't you test every single span, cable of similar manufacturer in similar conditions in the same subdivision, we still feel that that's a good bet that if you get out of 20 spans, if you randomly test 3 of them, that's a significant enough sample size to be respective of what the whole subdivision is.
And you can you get into more detail about your cable testing? How long do you do this before the injection crew comes in, and what else are you doing while you're testing your cable?
Okay. In the preliminary stages, we VLF'd the cable well before we had signed a purchase order to do the cable injection because it was part of the priority. What happens now is that Steve's probably about 2 years ahead, and he's going out to the next subdivisions that are, looks like it's going to be about 2 years down the road, and those are the subdivisions that he's testing now to prioritize to see if we need to adjust the priority. We did not VLF test every subdivision back in 2008. We went to the ones that, the top 6 on the list. So we didn't get into the ones, because right now we've moved our way and we're injecting cables that are in the early 80s about right now. So we're on to about 35-year-old cable. So from that standpoint, Steve is randomly sampling subdivisions that are probably in the 2 to 3 year replacement window, just to see if we need to jockey one priority-wise over another one. Given the fact that none of them have had a cable fault, and they're probably of similar age, so the VLF might be a slight indicator of which one should go first, but more than that, typically it's going to be, is there a reliability statistics reason that subdivision A should go over subdivision B, because it's got a lot of radial spans or it's got long loops that are going to have a higher customer impact. That tends to be more of the situation for the subdivisions that have never had a fault. It was before my time at the City of St. Charles, but it looks like they were pretty consistently buying Essex cable through the 70s and 80s, so there wasn't a change in manufacturer that would cause, one subdivision from the same era or half of a subdivision to be a different cable manufacturer. We found some of that. It's almost like somebody found a couple of reels of some other cable manufacturer, and those ended up in there. We've had a couple places where we've run into some strand filled, which is uninjectable. But other than that, we've pretty much worked our way through the subdivisions, and Steve's just a couple of years ahead looking to jockey priority. But with respect to what we do, the test for us is only a 15-minute per span. So the crew takes the cable, does whatever switching to take that span out of service, sets up the tan delta on it. It's a 15-minute test with the equipment, records the results on the laptop for Steve, and then they plug the cable back in and move on to the next span. So they'll test 5, 6 easily in a day. Okay.
Thank you. Did you test any jacketed cable?
Yes. Yeah. Some of the later 70s, we did get into some that was jacketed, and again, it's sometimes a hodgepodge where it's all of a sudden there's half of the subdivision has this general jacketed cable or whatever. So there are jacketed, and those obviously the neutral tends to be in much better condition than the unjacketed. Okay.
Thank you. And then the next question is, have you done a cost analysis to reflect future money saved by reducing previous outages?
Have we done? We haven't done a monetary quantification of what outage minutes cost our residents. As a smaller municipal run, so we answer to a city council and a mayor. So those are the people we answer to. And I think more than monetary benefit is the inconvenience factor. So like I said before, we have our reclosers set in the case that it's animal contact or a tree contact on overhead, that it will reclose. So it'll try and save the fuse and reclose. So any of these cable faults ended up with a lot of times hundreds of customers who had blinking clocks just from a momentary, and not all, but enough of those were also contacting the aldermen. Again, a lot of the aldermen were collected in some of these outages. So we had some of these sustained failures that ended up including, the alderman's house. So they had a direct impact to them. But there were many others that would catch me at a city council meeting. Hey, why were my clocks blinking on Friday when I got home from work? And I'd have to explain that to them. So with respect to the cost or the avoided cost of not having cable failures, we really haven't gotten into that. We're fortunate enough that the perception and the customer service or customer reliability benefits are really what's driving the program from the governing or elected officials. Okay.
All right. Is reclosing used to find isolate faults?
We do not. We have not gotten into trying to use our recloser information to figure out where the fault is. Typically, we're going to be able to find the fault by what customers call in. And again, all these are single-phase fused residential loops. So when you have a cable fault, anybody on that side of the fuse is going to have an outage, and they call in. So 100% of our problems are typically found by who calls in, and then it's a pretty easy troubleshoot if everybody on this side of the street between here and here is out. Well, those are these 6 transformers, and those are all fed from this fuse right up to the normal open. So a lot of those we pretty much can troubleshoot just by who calls in.
And how long do you think your rejuvenated cable will last?
We're on a 40-year program. So the sustained process with the fluid that we've selected is a 40-year warranty, and we expect to not have to be back into these neighborhoods for 40 years. And by the VLF tan delta testing, there's all indications that the cable insulation is as good as new.
And how many feet of cable are you injecting a year?
That will vary based on, again, we've done it on subdivisions, and every subdivision is a little bit different sized. So some years it's 20, 30, 40,000. Some years it's 70,000. So it all depends really on what subdivisions are up for rejuvenation.
And what is the reason to use tan delta versus the TDR test used by Novinium prior to injection?
The TDR isn't going to assess insulation. It's going to identify where the splices are and the total, cable length and the quality of the return path using the concentric neutral. But the VLF is really a power factor test, so you're testing the quality of the insulation. What's the withstand voltage of the insulation at the weakest point of that cable span? So the TDR really doesn't tell us anything about the quality of the insulation or how degraded it is.
All right, it looks like we have time for one more question, and that is, did Novinium provide services for diagnostics, or were they only responsible for the rejuvenation?
Novinium offers a number of different methods and modes for providing the service. What St. Charles chose to do was have one Novinium technician with our IBW two-man crew doing the craft work. So with a union IBW shop, we were sensitive to not having either a non-union or a contractor do work that our people could do. So the method that we chose was Novinium has their technician. Our lineman will take the span out of service, remove the elbows from the transformer, and at that point we turn it over to the Novinium technician, who will perform the TDR and the air test to determine if we are going to inject that span. If we are going to inject it, then our people will do the craft work to get the injection port installed on the cable. Then we turn it back to the Novinium tech. He'll initiate injection, and then when the fluid comes back in, or when the fluid comes in at the other end, then we'll do the craft work. Then our crew will do the craft work. So there was an option to totally contract it out. We didn't select that option. So it's a blended team between the Novinium technician and our crew. And I will tell you that the TDR and the Novinium technician really matter, because when there is a splice that we consider may be accessible, having that TDR tell you about how many feet out it is and trying to pinpoint where that is to dig the hole to try and find the splice is very important. So that Novinium tech is kind of a critical team member to helping, if we do have to find a splice, to try and pinpoint that using the TDR. Okay.
All right. Thank you so much, Tom, for taking the time to speak with us today, and thanks for everyone for joining us. If we didn't get to your question, we'll make sure that Novinium reaches out to you individually. We hope you enjoyed the webinar, and stay tuned for our next webinar in our Masters of Reliability series. Thank you.